chicos y chicas! Today we're going to talk about how to convert the data into common denominators, because if you notice, we have eighths, we have fourths, we have halves, but none of them are necessarily the same. So we have to make common denominators, so equivalent fractions. And I'm also going to show you how to make a line plot with these fractions, because in the last video you learned how to make a line plot but with whole numbers, and that is super easy. But now I'm throwing a curveball and adding fractions. But you're a very smart set of students, so I know that you're going to get this very quickly. Okay, so common denominators, we have talked about them before. It's nothing new, so I'm just going to quickly go over them. We first notice our denominators. We have eighths, we have fourths, so eighths, and we have fourths. We have halves, and that's it. Okay, so remember, we are trying to make sure that we have the same denominator without changing the fraction, and that is where equivalent fractions come. Now, I put it like this. I didn't actually put the actual fractions that we have. I didn't put 7/8, I didn't put 7/4, because I first want you to realize which is the bigger number. Not the bigger fraction, but what is the bigger number? What's the bigger denominator? Not that the denominators actually change, because they're technically all the same size. It's part of one whole, which is a foot. Okay. So the biggest number that we see is the 8. So I'm going to make sure that I circle all my fractions that are not in 8. Now, I am circling those because I need to change those. Now, I don't need to do anything to the fractions that already have 8s. Okay, so I'm going to go ahead and say, well, this fraction needs to change. This fraction needs to change. This fraction needs to change. This one too. This one doesn't have any. I'm not going to change anything if it doesn't have any. And that one does not need to change. So I have to change 3/4, 1/2, 2/4, and 1/4. Okay. And I am changing all of those to, you guessed it, eighths. I have to change all of those to eighths. Now, if we were in the regular classroom, I would have you do it in your paper right next to this. But because we're not in a regular classroom, I have to basically do all the math here, and then I'm going to erase it. But before we do that, I want to make sure that you realize that even though you're changing the fraction, you're not changing the height. It's still the same height. We talked about common denominators and equivalent fractions. You're not changing anything. The fraction stays the same. And therefore, I am going to go ahead and move my whole number already. So because this is the same as 4, and then we're going to change the fraction. So I don't need to do anything to the whole number that is not changing. I am already, and so I'm going to just go ahead and do that to every single one, which equals 4. This equals 5. And everything is the same. Yeah. So I do not need to change the whole number because that is not changing. So I am getting basically rid of, or changing, not getting rid of, but I'm just transferring the whole number because that is not changing. Okay, now I'm going to go ahead and start with my common denominators. So to make common denominators, remember we have to make eighths. So I have, I'm going to erase this so it doesn't get in the way later. So I'm going to start with the first fraction. I have 3/4, which equals 3/4, and I'm going to multiply it times something to equal eighths. Remember, our goal is to get it to the eighth. Okay, so what times this number equals 8? So 4 times 2 equals 8. Remember, because we're multiplying, we're not changing the quantity of the size of the fraction. Whatever you're multiplying in the bottom, you have to multiply at the top, because 2 divided by 2 equals 1. So basically what you're doing is you're multiplying this whole thing times 1, and you know that whatever number you multiply times 1, it's the same. So 2 times 1 is 2. 3 times 1 is 2. 3/4 times 1 is still 3/4, but because you're changing it in this way, it's going to look a little bit different, but it's still the same amount, the same quantity. So 3 times 2 equals 6. So 3/4 equals 3/6. So now I can go ahead and change that. So 3/4 equals 6/8. Sorry, I put 3. I said it wrong when I said it. So 3/4 equals 6/8. Okay, so we're done with this one. Now let's go ahead and change the other one. So now we have 1/2, and we're still, remember, we have to get everything to the 8 because that is our bigger denominator. Okay, so 2 times what equals 8? 2 times 4 equals 8. So once again, whatever you have at the bottom, you have to do to the numerator. So 1 times 4 equals 4. And so therefore, now you know that 1/2 equals 4/8. 4/8. Okay, now we go to the next one, which is 2/4. 2/4. So 2 times what equals 8? 2 times what? I'm getting ahead of myself. 4 times what equals 8? So that is 2. And my brain already knew the answer, so I just said it. Okay, 4 times 2 equals 8. Therefore, whatever you do at the bottom, you do at the top. 2 times 2 equals 4. So then 2/4 equals 4/8. Oh man, it's so hard to reach all the way over there. And now we have the last one, which is 1/4. And let me just go and double check that I did not do 1/4 yet. No. So the good thing is that if you find yourself with fractions that are the same, let's say that this was 2/4, then I wouldn't have to do it again. I would just put the answer that I put over here because I know that 1/4, if it's 2/4 and then I have 2/4 over here, that's not going to change your answer. It's still going to be the same, so then you don't have to do the math. Unfortunately, in this case, I set up myself for making sure I do the math for all of them because all of them are different. 3/4, 1/2, 2/4, and 1/4 are not like the same, so I have to do the math. But once again, if you find fractions that are repeated, let's say 1/2 is over here, I wouldn't have to do this one again because 1/2 is still going to be 4/8. Okay, so now I go in 1/4. So what 4 times what equals 8? 4 times 2, whatever you do to the denominator, you do to that numerator. So this, I forgot to change this. 1 times 2 equals 2. So then 1/4 equals 2/8. Okay, now I have double numbers in here. What this means is that I am no longer going to use this when I do my line plot, okay? So you can go ahead and scratch those off. You're actually going to be using these ones and these ones. So like I said, because I don't have room to actually show the process, now I am actually going to go ahead and start building the line plot. We have to, the first step is noticing what is your biggest number and what is your smallest number. So 5, this is the family, and this is the height in feet, and feet looks really weird, but this is feet. So dad measures 5 7/8 feet. Mom measures 4 6/8 feet. Sister 1 is 5 4/8 feet, not fifth. Sister 2 measures 4 4/8 feet. Sister 3, 5 2/8 feet. Brother is 6, and I am 5 4/8. Okay, so it looks like my brother is the tallest in the family, and so I'm going to go ahead and start my number line, so my line plot. And the ending has to be 6, right? That's the biggest one. And now I'm going to go ahead and look for the smallest number. For the smallest number, I'm going to check first the whole numbers. So this is 5, 4, 5, 4, 5, 6, and 5. So obviously, we already have this as the biggest number, and 5 is just slightly bit smaller than 6, but really the smallest is 4. So I'm going to go look at this too. So mom and sister, out of both of them, who is the smallest? And it looks like my mom is 4 and 6/8, and my sister too is 4 and 4/8. So this is actually the smallest, but it doesn't really matter because for that you look at the whole number, and you do not want to actually put 4 and 4/8 in here. You want to go with the whole number. So I'm going to put 4. And now I'll count my whole numbers to check how many I need in here. So I already have 4. I have 4 for the marker and 6 for the marker. I am not counting that. So 4, 5, 6. Okay, so I only need 1 marker. So boop, that's at the middle. And this is 5. And once again, we try to keep our markers evenly spaced. So we don't want one bigger than the other. This video is getting really long. I am so sorry, but it does take a long time to really process whatever happens here, okay? So now what we're going to have to do is to divide all our whole numbers into 8s. So if you're doing 8s, the easiest thing to do, or any even number, is to cut everything in half. So I'm going to go ahead and use this color to represent 8s. And so that you can see. So everything in half. So right now it's in half. So this is half and this is half of a whole. And now I'm going to go ahead and put it into fourths. Now it's in fourths. I have 1, 2, 3, 4. 1, 2, 3, 4. So this is fourths now. Now I'm going to go ahead and cut that into halves. So see how easy it is to divide evenly in 8s. And basically, like I said, any number that is an even number is going to be much easier to divide because you can always just cut it in halves. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have 8 spaces, but really I should have 8 markers in between. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's where the 8s come in. Okay, so now that I have 8, my line plot divided into 8s, I can go ahead and start and label. Now, because it's not everything in here is going to fit, you don't have to label every single one of them, okay? Only the ones that you believe are the most important. And for me, the most important ones are the middles. That way I know when I'm plotting whether I have to go this way or that way. Okay, so this is 4 and 1/4, 4 and 1/4, sorry, 4 and this is 4 and 1/8, 4 and 2/8, 4 and 3/8, 4 and 4/8. So this is 4 and 4/8. Now, why am I putting the whole number? Is because if we're counting, it's still 4. Like, we're still at number 4. You get me? The whole number is 4. We still have 4 whole. So we have to put the whole number. And so then this should be 4 and 5/8, 4 and 6/8, 4 and 7/8. And this would be 4 and 8/8. But that equals 1. Remember, 8 divided by 8 equals 1. So therefore, there would be like 4 plus 1, which equals 5. So this is where we're getting the 5. Okay. So then I go ahead and do the same. 5 and, so this is 5. 5 and 1/8, 5 and 2/8, 5 and 3/8, 5 and 4/8, 5 and 5/8, 5 and 6/8, 5 and 7/8, and 5 and 8/8, which is 6 wholes. Okay, so now that I have this labeled, remember, you can go ahead and try to label every single one of them if you want, but it's going to get like very squished and it's going to be hard to read the numbers, which is why I don't label all of them. I only label the middle parts because it's easier to count. So this is 5 and 4/8, and so then this one, you know, it's 5 and 5/8, okay? So now we go ahead and plot. So that is 5 and 7/8. So this is 5 and 4/8, 5 and 6, 5 and 5/8, 5 and 6, 5 and 7. That is right here. And remember, we mark to indicate that we are done with that one. Mom would be 4 and 6. So this is 4 and 4/8, 5/8, 6. And our X's, try to keep them evenly sized. And then 5 and 5, 4/8. So, oh, that one's easy to identify because it's right here. And then 4 and 4 right here. And 5 and 2, 5. So this is 1, 2 right here. 6. I don't know why my brother left that. Okay. And 5 and 4/8 right here. Once again, we double check to see that we have the right number of X's. 1, 2, 3, 4, 5, 6, 7. I should have 7 people here. So 1, 2, 3, 4, 5, 6, 7. Okay, so now we have 7 and 7. I'm pretty sure we're correct, but we can go ahead and double check. We're going to pretend that we did. And now we label, right? We remember that you use this, if the data points, you use this side, this column right here to label at the bottom. So this is height in feet, okay? And you use both of them to have a title, because remember, line plots have titles. So that way, you know, other people, when they're looking at this, they know what they're looking at. So we're going to say a family's height in feet. Okay, and so then we are done. We have labeled our markers. We have labeled what those markers represent. We have the right number of X's, and we have a title. And that is it. Remember, so first step is identifying the biggest, not the biggest, but the denominator with the biggest number. And then you find common denominators. The focus is weird, huh? So common denominators, I'm gonna count like this instead. Common denominators by making equivalent fractions. You go ahead and change these, and then you start plotting by dividing your line plots, identifying what is your biggest marker and then what is your smallest. And for the smallest, remember, you are always looking at the whole numbers, not the fractions. So what is your smallest whole number and what is your biggest whole number? But with this, even if you have, like, let's say my brother had 1 and 1/8, then I would go to the next whole number. So this would be 7 instead of 6. And then you go ahead and plot. Remember to label and title. Okay, this is it. This is getting way too long. I think this is one of the longest videos I've posted. Sorry for it, but it's very important. Okay, boys and girls, see you later. Remember, we have a meeting at 2:30 where I'll be reading out loud a book. Bye-bye.